Hi, welcome back. So we are at the outline to discuss sets. Now, when it comes to sets, we have to understand the previous subject of lists. Lists are extremely good tool actually that suits container object application in so many ways. But they are not useful when we want to ensure objects in the list are actually unique. Say for example, if you have a song library that contain many songs by the same artist. And if we want to sort through the library and create a list of all the artists, we want to make sure, of course, there is no duplicate of the same artist again and again. And this is exactly where sets come in. Sets some kind of a form from mathematical background where they represent an unordered group of usually unique members. In Python, sets can hold any hashable object, not just only numbers. So hashable objects, what I mean, are the same objects that can be used as a key in the dictionary, if you remember. So you can have numbers, string, tuple, but you cannot have lists or dictionary, just as we discussed in the dictionary outline. Now let's get back to this example of a song and an artist and library, etc., and illustrate that. So here I have created a list. You can see this is a list that contains number of tuples. So in the first tuple, you have two arguments. One contains the song name and one contains the artist name. Now in this song library, as you can see, we want to actually get to have a list of all the artists inside this list. You could see some of them are duplicate, like Guns N' Roses in this case. You can see if I want to extract this list of the names, I shouldn't have the duplicate. Here's the set can be really useful. So what I'm going to do, I'm going to create here kind of a variable called artist, and here how I instantiate this set. So this is one way to create the set. So the next thing I want to do, maybe to loop inside this list by song and singer in the song library, this variable of list. And I'm taking advantage of having to know that each element within that list is just a tuple. That's why I use the unpacking mechanism. Similar to that when we use dictionary, if you remember. So what I'm going to do here, I will reach to the artist set and I use the add. Now add, it's a built-in function. You can add whatever you want. So let's add the singers in this case. And then we are going to print the set of artists. So if I would have to run this, as expected, I have the first artist, second, Vixie, Sarah, Guns N' Roses, one time occurred. So there was a unique extraction of that. So you could see one of the most important features of having said this one, but not only this one, we'll be discussing further in a while. Now, I want you to know that sets like dictionaries are unordered. They both use an underlying hash-based data structure for efficiency to make the lookup very fast. That's why we cannot actually look by index, just like we did in the list. If I want to ask here, is this artist in the artist list? Now here I should have returned by yes or no, or true or false. Let's try to actually print. You can see it's true because it's inside. If XYZ or any other unexistent name, I should get false. So this is another useful feature of having set to be structured in your project. Now, as we said, this primary features of uniqueness, it gives it a very strong presence. It's not only primary purpose, but sets are most useful when two or more of them are used in combination. Most of the method on the set type operate on other sets. So what I'm trying to say here, if we have like sort of two different sets and I want to finding out what are the common intersection between them, let me create two quickly set and illustrate what I'm trying to say. So here we have two sets, set 1 and set 2, and you can see both of them are actually structured to contain number of those artists. And the question is that if for some reason we want to find out some intersections between them. So I'm going to introduce you to three important built-in functions or methods that can be useful at this time. So let's print here for all. That means I expect the result in this print line will print every artists in both lists. Here I'm going to use a set1, and then I'm going to reach out to this function or method called union. And the second thing I want to introduce you to, let's again call both. In this case, what I'm going to do, I will reach to set1, and then I'm going to use here an intersection with set2. Let's go to the third one, and let's go with either one. And in this case, I'm going to again reach out to set1, and then I will use something called symmetric difference, and in symmetric difference function from set2. So let's look at all. Here, he just went and print every artist in both lists. And once again, I want to emphasize, look at the order of a printing. You can see they are not following an alphabetic order. There is a hash, as we said, mechanism of storing. Anyway, you can be sure there is no duplicate. So all the artists in both lists have been printed. Now in both means what is the intersections between both of them. So you could see very clearly the Guns N' Roses is the intersection. Finally, the either one of them. So you have here something related to what is exist in a unique list. So for example, this is only exists in this list, but Guns N' Roses happens to be in both lists. That's why this will be out. This is exactly the meaning of the symmetric difference. Also, I want to introduce the same exact idea, but this time I'm going to use a concept called the is superset or is subset. What I'm going to be using here, let me use, again, I will rely from set1. Is set1 a superset of set2? So you can expect that will return some sort of true or false. And the second, set1 subset, not superset of set2. And finally, I'm trying to find out if set1 is a difference from set2. Okay, let's try to run these and try to figure out what the result would look like. Question is that, is set1 a superset of set2? The answer is false. It is not, because there are some items here are exist in set2, but they are not exist in set1. But let me actually change one of these artists here. Now, if I run one more time, you can see things is changing. Now we could say that set1 is really a superset of set2. It means every item in set2 already exists in set1. And the second question is set1 subset of set2? Of course, obviously no, because if this is a true, it should be false. And the final thing is set1 difference from set2. The action happens to be yes, it is different, and he picking up it different in which way. So there are two artists that exist in set1 but not exist in set2. Now I could do the same exact thing by printing, instead of looking from set1 to set2 perspective, I can call set2 to set1 perspective. I leave this for you, but the general idea I should say it should be clear to you. So that was all about sets. Next we'll be looking at the final subject of data structure, that is queues. I will see you then.